was an assistant professor in the Department of Artificial Intelligence and Machine Learning at Symbiosis International Deemed University. There, she taught courses such as Big Data Analytics and Data Structures and Algorithms, coordinated undergraduate
This meeting is being
projects,
recorded and summarized.
and actively promoted industry-centric education for AI/ML students. Prior also, she focused on teaching a wide range of subjects from the basics of computer science to advanced topics in AI, ML, and latest trends in computer field. Dr. Mahajan has a significant contribution to the field of AI through her extensive research on computational humor and emotion recognition in multilingual text using semantic based analysis. Her work includes the creation of datasets for code mixed emotion recognition and applications of both machine learning and deep learning models to solve complex problems in regional languages. She has authored numerous research papers published in reputed SCI and Scopus journals and has presented her work at international conferences. Her research interest includes natural language processing, sentiment analysis, emotion recognition, and high performance computing. Dr. Mahajan is recognized for her clear communication and ability to simplify complex concepts, making her an effective educator. In addition to her academic role, Dr. Mahajan is actively involved in promoting holistic lifestyle practice, helping individuals manage lifestyle disease naturally. She is also dedicated to spreading awareness about the importance of HPC as a certified master trainer from CDAC and AICTE, leveraging her expertise to guide the next generation of AI professionals. We are very fortunate to have an experienced academician as our resource person for today's session. I cordially welcome Dr. Rutal S. Mahajan ma'am to the session. Welcome to this FDP ma'am.
Thank you so much for such a nice introduction, madam. I'm also privileged to join this ATAL FDP and to talk on my all-time most favorite topic, that is on HPC, and which is at the intersection of AI. So, without wasting, yes, sir. Okay, so without wasting much time, I will be starting the topic, which is high performance computing applications, which is, we can say, powering innovations across the various domains. So let's start with that. But before going to anything regarding this HPC, I would like to show you this couple of pictures that you might have familiar with. Like this picture is of Jarvis of an Iron Man, then some humanoid robots, right? And from the science fiction movies, these are the pictures from the science fiction movies. This is the Wall-E robot, and this is from science fiction TV series on the humanoid robot Wiki, which is assisting in the day-to-day task. Now, why I'm showing all this? Because decades ago, this seems a science fiction, and we have seen all these things as a science fiction. We might not know that this would be the reality. And if you just think in the today's era, all this are now no more science fiction. They are now reality, we can say. It is the part of our life, be it a chatbot or humanoid robot or any spatial task robots. We can say it is part of our routine life, right? So how this all starts? The rise of an AI, this starts with the Alan Turing's this question, can machines think, in 1950, and he has given the term artificial intelligence. Now it has evolved such a way that the computing also grows, and first initially it was grow for the, let's say, spatial purposes, and then it comes to our daily life. So in today's session, I'll be talking about the introduction and the understanding on the overlaps of HPC and AI and the big data and the various fields where it is touching. The importance of HPC AI convergence, then the evolution of HPC from in the perspective of we can say architectures and AI, then IoT, edge computing. In various sense, we will be looking at the evolution of HPC. We will be discussing some real world case scenarios, applications in various domains like data science, AI, IoT, and many such. As I said, this is means powering the innovations across the domain. HPC applications means it is powering the innovation across the domain. So it will not be limited to that small area. It will be touching various areas. We'll be discussing on that. Different challenges I'll be covering at the last to scale and develop any HPC application and some points on the future landscape. So let's begin. We will start with the HPC definition. So I'm not going to talk about the formal definition of HPC. But when I say HPC, what it comes into your mind? Probably the simplest way what we can do is we just type on Google and ask for the definition of the HPC, and probably 14.9K or more than that, it's come from the Google giving the HPC definitions. Right, so various definitions we just find. Few of them I have quoted over here, like uses supercomputers and computer clusters to solve the advanced computation problems, which is given on the Wikipedia. Then a branch of a computer science that concentrates on developing supercomputers and softwares to run on the supercomputers. The main area of this discipline is developing parallel processing algorithms and the software, and many more other definitions. But what lies in the core? What does actually it mean? You can see, I just like to make emphasis on this picture, which is, I can say, relating this HPC definition very well. Means this is a one giant elephant, and we can say it is one. That is one problem. We are having one solution, and how we can solve it. For that, we are having some resources. So this realization can be made using this elephant and this leopard and the laptop. Over here, you can see the size of the problem is the is as giant as the elephant. The resources we are having, like we are having laptops or desktops, personal computers, and the speed means how much it takes to solve this big problem on the small resource. So of course it will not at the speed of this leopard, right? So what we can say means all in a synergy that it can't fit on a single PC. If we talk about current age problems, then that data can't fit on a single PC. It needs more than few GBs of RAM or few more 100 GBs of disk space to fit a problem on a particular, we can say, storage, right? To solve it, to start solving it, right? So when the one aspect of this HPC definition is associated with the huge size of the problem, then it takes very long time to run on the PCs, let's say months or years, but it might take only few hours for the computers to solve that problem. Means our HPC lies over here. Means what kind of resources we are using. Depending on that, we'll be getting the speed of that solution that we are seeking. So let's see how this intersects with other or various domains. So you just see artificial intelligence. This is, I think, very well known to all of you that in artificial intelligence, where we are means aware of getting some computers solving difficult tasks through experience and observation, that kind of techniques we learn, right? It gives the idea about that. Machine learning is some narrow domain in the artificial intelligence, which works with the adaptive models, which learns to improve the performance on the given experience. It also involves some sort of statistics, and if we narrow down more, it is like artificial neural networks and deep learning. Now, these terms are no more, I can say, unknown in today's era, right? So these are very well known terms. So where this HPC fits, why I say that AI, data science, big data, and HPC is a perfect union. Now you just see data science lies over here somewhere at the intersection of machine learning or deep learning, AI, statistics. It works majorly with the data. So we can see nowadays the data, which is the fuel for all these techniques that we are using to solve some sort of problem. So that's a big data. Means it's a type of a real world data nowadays, and techniques which deals with that large or huge amount of data. There are different aspects of that big data. I'm not going to cover that, but we can say that it is the fuel for all this thing. Now we need to identify, or we can say discover some interesting patterns from this data, which is scattered, and let's say it's a huge amount of data. So for that knowledge discovery in the database, this processes or these techniques are there. And data science, which focuses on data management, visualization, and it involves in the task of gaining insights from this large unstructured data. So where the HPC fits over here, it's AI, ML, DL, and data science, big data thing. So to work with all this thing in a harmony, we need resources, because all these things are resource hungry. As I said, if we try to solve a problem, which is in a size of a giant like an elephant, and we try to solve it using the resource which is tiny like a mouse, then it will take more time. We probably not get the results in an expected time. So over there, we required HPC. So let's see that. I would like to show you this global startup heat map on high performance computing. Now it is showing the distribution of 549, means different startups and emerging companies across the globe by Start US, this firm, right? And this data is from 2023. You can see there are plenty of emerging companies we can see all over across the globe. That is 549 startups we can see in at the end of February 2023. So it is the current landscape of how HPC is growing. Now you just see why I'm showing this, because you just see the top 10 innovation trends which are impacted by HPC, means this 549 startups that we have seen across the globe, right? So that is just at the end of 2023. Now, the majority of the startup are in 30%, that is in the AI domain, right? Then we can see the cloud computing, some in edge computing, quantum computing, then cybersecurity, and many different areas we can see over here. That distribution we can see over here. So we can see it's important to know or learn how HPC is impacting AI. So let's see that. Another thing is why it is important to see the HPC AI convergence, means how HPC is grown, or reverse, I can say, how AI has grown with the growth of that resources, enormous computing resources. Like over here, this graph shows the size, AI, how AI enhanced the HPC market, means by this 549 startup, and that is true in a majorly in the AI domain and various domain associated with that, right? How it is impacting the global market, right? You just see over here in 2020, it is like this one, right? In 2023, it is $2.6 billion, right? And it is means expected to have the global this market to be grown by 9.4% from 2024 to 2023, means that is in terms of software, services, hardware, right? So along with the time or technology, this resources and everything, this market is also growing. So it shows the huge potential to invest our time to get skilled in AI and HPC. So let's see that again, coming to our topic, why it is a perfect union. So I would like to show you this simple analogy. Like you can consider there's a gas station. Big data is a fuel, right? You are having a car, which is we can maps it with the AI model, right? And HPC systems are the engines of this car, right? So how they all work in a sync, that big data is a fuel that powers the AI model, that is this car, and HPC systems are the engines of this car, which processes this data efficiently in a real time. So that is how we are getting essence from this big data, and that is how it is working efficiently. So let's see the emerging trends are how HPC has evolved with the AI and other domains. So this is the evolution chart, we can say, of HPC architecture, right? Now this is given in terms of you just see over here the timeline is given from 1990 to 2020 onwards, right? And over here the speed we can say the performance of the computing system is given in terms of flops, that is floating point operation per second. It is generally used as a measure of performance of the supercomputer, even any computer, we can say, not only the supercomputer, for any computer. So it is represented by flops, means in one particular second, how many operations, floating point operations we can run in a concurrently, parallelly, right? So you just see over here, it is in terms of, it started with megaflops, right? Lately, in the 1990s or before that, then gigaflops, teraflops, and petaflops, right? Then you just see exaflops. Now you just see over here the exaflop barrier is already we can say achieved. So let me simplify the things. Teraflops means in a 1 second 10 raised to 12 floating point operations are performed. Petaflops means 10 raised to 15 floating point operations are performed. So you just see over here, this is the first 500 supercomputers, we can say, of that particular time. are representing this thing, right? And this shows the total sum of that, means total computing power, right? And this shows the number one, how the top performing supercomputer is doing. So you just see, if you want to see the top performing computer, which are the latest or top supercomputers, world's top supercomputers, then you can go through this website, that is top500.org, right, which lists the world's top supercomputers using a program called HPC LeanPack, high performance LeanPack. Now, there are different measures. Based on that, it is decided that which is the, let's say, fastest computer, and different measures. Based on that, we can compare the supercomputers. You can go through that. Currently, the fastest supercomputer is the Frontier, right? Right before, I think a few weeks back, the fastest supercomputer is now no more Frontier. It is something else. You can just try and go searching this top500.org, that any supercomputers from India belongs to this list or not. Now, let's see how it has evolved, right? Yeah, I must tell you which is the fastest supercomputer now, right? So, which is at the California, AICTE. So it is installed at the Oak Ridge National Laboratory, Department of Energy, USA, right? So it has now crossed the speed of Frontier, and it is now the fastest supercomputer. So for Frontier supercomputer, we can see how fast it is working. It is designed to process AI workloads for large-scale research works at the peaks of 2 exaflops. 2 exaflops means we can say 10 raised to 18 operations per second, right? And the current top supercomputer in the world is now not a Frontier, right? It is having 1102 petaflops, but now we are having faster than that, that is AICTE at the California. Now, let's see how all this thing has started. So the roots of this supercomputer is late history in the 1947. You can see this, some sort of wirings and all this. This is nothing but a room-sized computer, our first ever computer in the history of computers. So this is nothing but a ENIAC, right? It was built during World War II to solve complex military calculations quickly and efficiently. So its primary purpose was to assist the US Army in calculating firing tables, right? So for that, these computers were used. They were used to aim and fire weapons accurately under different conditions. So that was the primary purpose of building this kind of huge supercomputer. Now, another one in the history, we can see the Cray supercomputers, which was built for the weather and the defense. It was also used in a US Army. It was in the era of 1970s to 1980s. Why? Because in this era, this was called the Cray era, because during this time, so many different versions of Cray supercomputers comes into the market. Yes, market means they were actually commercially sold. There were not only the single computer like this one, ENIAC, they were commercially sold. And you can see this picture of this Cray supercomputer, which is at the Museum of America, Georgia. You can also find such other Cray supercomputers at different places like London and the many other places, right? More than 70 supercomputers sold at that time, Cray 1 supercomputers. Now, let's compare this thing, how we evolved. Now we see, let's compare the first supercomputer and this supercomputer. Now we know this very well in our day-to-day life. We just use it. That is nothing but our mobile phone. Yes, it is comparable to our that first supercomputer. Now let's see that. If we see the size of the first supercomputer is 1800 square feet, means the room size supercomputer. Now this is a tiny supercomputer. Now you will understand why I'm saying it's a tiny supercomputer. It fits in our hand, right? Weight, if we talk about the weight of this supercomputer, then it is 30 tons. And for this, it's nearly 150 to 200 grams, right? Processing power is 5,000 additions per second. All right, we are not even talking about the floating point operations, right? Over here, 5,000 additions per second. Over here, our mobile phones. This is, I'm talking about the Samsung S3, that mobile phone, right? So it is billions to trillions operation per second. Means you just see how powerful it is compared to that age-old supercomputer. You just see the first supercomputer cost around 5 million US dollars. That too in 1945. Now this cost around 200 to 1,000 US dollars. So the essence is this, means this is for military calculations, and we can do any general purpose computations, or even it can do many other intelligent tasks compared to this special purpose supercomputer. So the point is, we have grown in terms of resources so well that in modern era, we are using the better computing device than the supercomputer of that time. So let's see how supercomputer looks like. Yes, nowadays also supercomputer looks like this kind of big size, room-sized settings, right? I'm just sharing this photograph from I visit in the CDEC, where we have seen this Param Siddhi AI Param supercomputers, right? You can go and check on the top500.org website that any of the supercomputers from India exist or not. So let's see. What's happening? Okay, so same like Frontier at USA, it just looked like this, right? The huge room-sized settings, right? Now, let's see how HPC is used in edge computing. So, edge computing or IoT, we can say, are the area which is generating large quantities of data, and they has to process large amount of data. So, and the essence is that we need to give the performance in a no time, means the answer or solution at that particular edge device in a no time, right? So in that context, we need a processing power, high processing power at this edge device. So instead of every time sending it to the central data centers, so we need HPC or high-speed computation with limited power and space at these devices. So how it will be working, you can check it like for that different edge accelerators are installed at this edge devices, and different programming environments on this edge with the HPC are used like SQL, NVIDIA CUDA, and many other programming models are used. Now, few of them I have mentioned over here, but I'm not going into that detail of this. You can later on find that different HPC applications can be created using this kind of different programming models like CUDA or OpenCL, SQL, OpenMP. Right, this survey, there are many other options as well. This survey is given in this article, right? You can just check it out in detail. right? How we can create this kind of HPC applications using any of this programming models. Now, it's getting stuck. Okay, so this is the, I think probably you might have learned these things in the previous sessions, that how HPC and the parallel programming models are working, right, with the distributed memory, shared memory, or the hybrid model, right? So accelerated computing models, right? So I'm not going into the detail of these things. Many eminent speakers have, I think, covered these things, right, very nicely. Now, let's see. Yeah, this programming part, I'm just skipping it. What are the key technologies? If we talk about HPC applications in IoT and the edge computing, then what are the key technologies involved to implement those things? So let's see, if we talk about the hardware, then NVIDIA Jetson, the compact HPC enabled edge device, which is optimized for AI workloads. You might have, if you know, this is launched, its recent version is launched with enormous computing power. NVIDIA's CEO Jensen Huang comes with that device in a hand, taking out from the microwave and showing that it's a supercomputer, and it is a very cost-effective solution for our, we can say, the routine applications if we want to build that. Another is the Intel Movidius AI accelerated processor for the IoT devices, right? And different software like the NVIDIA HoloScan, Edge AI frameworks like TensorFlow Lite, PyTorch Mobile, NVIDIA DeepStream, right? Also the Edge analytics tools. We need to get the essence from that data, right? So that analytics tools are used for the networking, the 5G network, which ensures the low latency communication between edge devices and the cloud server, which is used. It is different than the communication in between the, we can say, the memory and the resources of the supercomputer. It's an InfiniBand. That's a different thing. This is for setting up the HPC applications with the IoT or the edge devices. Now, let's move on to how it is used in various domains. So let me discuss first the first use case, that is a real-time 3D surgical guidance fusing preoperative and the live data. Now, this is given on, this is shared in the detail how they have implemented this thing using NVIDIA HoloScan on the NVIDIA's developers website, right? It is taken from there only. So what they are doing basically, or what problem they are solving, the objective is to provide surgeons with the real-time or accurate guidance during minimally invasive or robotic assisted procedure. Now, what happened at the time of surgery, this kind of surgeries, doctors are generally having the data in the form of MRI or scans, right? They used to study that, and then with their own memory and their own, we can say, expertise, they used to put the incision and do the surgical procedure. Now, how this thing will help, you can see this pink part. So it this thing is visualized using the software. Now, what it is doing, the NVIDIA's HoloScan, the software, use the preoperative data, right? Preoperative data like MRIs and different scans, right? And it fuses it with the real-time means that operative imaging. With this means this operative video or live video streaming is there, right? So it fuses that data with, which is available as a pre-operative data, right, with this thing. So it requires precision as well as speed, okay? So for that, we require the, for this complex calculations, because we need to highlight the particular domain, right? And since it is involved in the surgical procedure, it should be accurate and it should be timely itself, right? It should respond quickly. So it requires the AI, accelerated computing, and the advanced visualization system. So over here, HPC is required, we can say. Let's say another real world applications in the domain of data science and AI. Now, uh, I'll be talking about why data science, because data science involves the where data science fits into this, right? So we can say that data science involves the cleaning, processing, and analyzing massive data sets to extract the actionable insights from this big data. So this is our fuel. From this, we want to extract some, let's say, interesting insights or interesting data. Then data science techniques or that visualization techniques are used over here. Now, why we can say why it is important to talk about this data science applications, because data science applications means data science techniques when we apply to any data. So it requires machine learning, deep learning algorithms, which is powered by this AI model, right? To interpret the patterns from this data, and it involves some complex calculations and predictions from that data. So it leveraged the HPC platform, means it uses this engine, and we can say it accelerates, it gets the insights from that. But if that engine is powerful, then only we get this insights in, we can say, very timely manner or quickly. Means we can say that getting insights from that big data, or let's say raw data, that task is accelerated by HPC accelerators, we can say HPC devices. So let's see another case studies in the data science and the AI, like climate science or earth modeling, right? You can see over here, this image is regarding over here. After coming here, I just means, initially when I was in India, I was not used to looking at the weather and the forecast every day. But since over here in the USA, we can see that there's a huge change in weather from today and the next day. Suddenly, weather changes. So people used to see this forecast every time they just walk outside, right? So, what if such forecasts are not timely and not accurate? It's of no use. Means we need that forecast beforehand, and it should be accurate. Then only people will means use it, right? So HPC helps the process that sensor data, which is in terabytes and large quantity, from the satellites and environment predictions, and produce the effective insights from that and show this kind of visualization. So for that, we need resources that can handle all these complex parameters and do that visualization most effective manner, and along with that, timely and the accurate manner. Okay, so another example is like Earth system modeling. So NASA uses this kind of, it has modeled uh, our Earth system and forecast different global warming trends. You can see over here from past historic data to means 80s, 18th century to means 20th century, and so on. It has predicted means past data and how it has making connections with the complex parameters, right? And it is predicting the global warming trends. So this is how HPC is used in the climate science and the earth modeling at the crucial level. Another application is the drug discovery simulations using molecular data. Means HPC helps this reduce the execution time, or we can say the predictive modeling. Like so many complex calculations are involved in this protein simulation, and many statistical tests are involved in that, right? So which are compute intensive in the nature. So this kind of things are used, uses the HPC resources, and it can be speed up. Now we will be looking at its detailed use cases of the recent time, right? Just stuck. Yeah. Another is the genomics and the bioinformatics, right? It provides the necessary computing power to perform large scale gene expression experiment. Again, as I said, this it involves the complex processing of this, we can say, the gene expression experiment or related to genomics, right? So it is the resource hungry. So for that, it requires the HPC. So it gives the results that we're supposed to get in years or hours or more time. We get it in a significantly lower time, right? So that is the mainly the use case of the HPC in this kind of different domains, right? So yes, another thing I want to make emphasize on is this precision medicine approaches. Now I'll be talking about this in detail, the recent application of this. Let's see that. I'll be coming to that later on. The financial analysis. This is also one of the trending application and the crucial one, right? For the fraud detection, risk analysis, and algorithmic trading, right? Now, why it requires the HPC resources? Because these calculations of trading are dependent on various factors, right? And even it becomes complex in the era of the social media, right? So how that different factors affecting this financial analysis and all, we need to observe that large set of parameters, right, of which affects the data, right? So for that, HPC is required. If you want to explore more, right, you can just see JP Morgan has used thousands of NVIDIA GPUs for real-time pricing and overnight risk estimation, right? And they have used some sort of graph-based computation for risk management at this particular places and the server. You can go through and check it later on in detail if you are found it's interesting. Now, another case study, I'll be taking it from the this modeling of aircraft engine, and this is majorly used in the US, in the Army or defense or this kind of vehicle simulation, engine simulations, right? Now, it involves complex fluid dynamics, we can say, principles and equations while running this engine at its full capacity, right? So before running that, it is in actual, right? It is always a good idea to have its simulation. So that simulations are also not that easy, right? So many parameters are affecting that thing, right? So it is computationally very intensive. So it also requires the HPC resources. So this kind of application can also be modeled on the HPC devices. Now, most favorite one, we can say the most trending one is training the deep learning or machine learning model over large data set. That is, we need to, nowadays we can see it's an era of AI and the intelligent era, right? So it involves using various devices, which is intelligent one. So how they are working intelligently? So for that, we need to train those models on the large or enormous amount of data, right? And that training time is comparatively larger if that data is larger. Means we are having the fuel. We must have that capacity to means process that fuel, right? So that capacity comes from the HPC resources, right? So I would like to make emphasize on this recent case study, right? You can see over here the Elon Musk has built that XAI, right? That company, right? For that, it has created a giant supercomputer in Memphis. That is, he started building it in a lately in 2024, and it is completed in some 100 plus days only, right? So why it is important, right? Let's see that it launches a major AI supercomputer facility in the Memphis, right? It is used for cutting edge AI development and research. As you know that he's involved with creating that autonomous vehicle, right? The Tesla car, right? And apart from that, so many things are that which involves the AI and intelligent things, right? To support all these things, he has created this supercomputer facility. Now, if you go and search regarding this giant AI supercomputer at the Memphis, right? You can see it's a big city, right? It's just like a city like setup of this supercomputer. So it's a massive computational power, I can say. It takes the city where it is located, right? It is consuming most of the electricity power, right, for running this device, right? So we can say there is more than 100K GPUs which are running for this creating this HPC device, this supercomputer, which is actually used to train the advanced AI models. What it means, what is the importance of this? Then we can say it strengthens AI's position, XAI's position in the AI industry. Of course, everyone wants to be the AI giant in upcoming years. So he has invested lots of money to create this. Now let me show you the another one. Yes, he has created the another mega data center in the Atlanta, which is just, this is the news of just a few days back. And just initial weeks of February, we just got this news, right? So it's a matter of 2025. He has invested $700 billion, and for creating this mega data center. Now it consists of more than 12,000 NVIDIA GPUs. Primarily H100 GPUs are used over here. And what is the main purpose? The main purpose was to accelerate AI development and model training for different applications, right? So again, the purpose is to reinforce the position of XAI in the global AI market. Now, let's see another one. It is stuck. Okay. The one that I was discussing earlier, that precision medicine, right? We have seen that the brief about this in the case studies of AI. Now, this is also the recent breakthrough we can see from the AWS, and in the collaboration of this MSK, means the Cancer Research Center. It is they are using HPC and AI. Now it is predicted that by 2040, so many deaths are predicted due to cancer. So their main goal is to come up with some sort of data and intelligent insights from the whatever we can say procedures or solutions we are having, right? So they want to create personalized treatments, and the precision medicine means particular specific to that particular patient only. So for that, it requires a complex simulations, and the calculation involves with the genomes and the DNA and the different clinical data, right? So for that, they have means collaborated and worked on that, right? So for that, which has a huge impact on the patient care, like it will be creating the personalized treatments and improved diagnostics. This is also, you can see in the on the Microsoft's website, AWS website, regarding its recent breakthrough. um, yeah, another one is this one, Microsoft Majorana one chip HPC. Now, this is also the recent one in this February itself. You can see this tiny chip which fits in a hand, right? So it is like a tiny supercomputer, right? So Microsoft has declared they have created this chip, right, which is it is claiming that it's a quantum processing chip designed for the HPC and the development of HPC systems. And they claim that now quantum computing is not decade ahead, right? They are just few years ahead. Means we can achieve those things in a years only, right? What is the significance of this thing? They have created a new qubit type for enhanced performance, and the scalability is improved with this. Like this quantum computing can be scaled more effectively within the HPC environment. Means they can work collaboratively, we can say. Quantum computing is a different thing, and the HPC environment is a different thing, but HPC environment work well with this kind of chips, which can handle the large data sets and complex simulations. So what is the impact on AI and in HPC? It will give the robust, error-resistant processing for the AI, and it boosts the optimization and the high-speed computation in the HPC setting. So what we can say in a summary about this kind of development of quantum processing chip, it will nothing but it will merging the quantum processing and the classical computing for the advanced solution. HPC, we can say the classical processing, classical computing, but with the huge amount of resources, computing resources. Quantum is the different thing, but this is how Microsoft has given a way to combine both things for different, we can just think of different applications that can be solved now using this tiny chip. Now, let's see, we have seen this different applications. What can be the challenges? So we can say the scalability and the cost, right? So high cost of infrastructure and the maintenance, which limits the accessibility. Building HPC device is not that simple every time, right? So the solution is a cloud-based HPC service, which offers the scalable or pay-as-you-go models. Different service providers are there, right? Also, it comes with the data security and the privacy, the large-scale data storage and the computation. It poses risk on the data that we are working on, right? So federated learning or secure multi-party computations. Now, why we are talking about this thing? Because these are the area where you can go in depth and create the new, I can say, breakthroughs, right? Another problem is the skill gap. We need some specialized training in HPC programming models like MPI, OpenMP, CUDA, and many parallel programming models like this to move ahead in this direction. And yes, AICTE and ATAL is doing well to bridge that skill gaps through this kind of programs, right? Yeah, these are the different solutions are given, like training specialized courses on this should be given, and the collaboration with the real world projects with the industry, academia, and the open source repositories should be there. There are many for in this domain, right? You can find many NPTEL courses giving the basic insights on parallel programming and HPC fundamentals, which is recently, I think, launched by SIDAC. right? I have done this thing to include some basic things into parallel, means including the parallel programming concepts into the core subjects to make students aware of these things, which is very crucial for the new age development, which enhance their understanding of the core subject. Along with that, they get new knowledge of this parallel programming, and they understand why that core subject is important in context of this parallel programming as well. So in the future landscape, I'll just say few things only with this provided links, which you can go through later on. AI-driven HPC systems. These are the few key projections I'll be marking over here. By 2035, AI-driven systems are predicted to power over 75% of all scientific simulations. Now, this is given in the Frontiers in HPC for Health in 2020. So you can see the development and the current era. It is quite true. We can see how it has become reality. Market growth, the global AI and data science market is expected to reach $1 trillion by 2030, with the 60% of that driven by HPC enabled innovations. Data explosion and the transformative potential of that data generation, which we can project that to reach 175 zettabytes by 2025. 2025 is not far away. It's just, we are in a 2025. So we reach that point, right, which necessitates the real-time processing by the HPC systems. That's why we can see so many, just in the previous slides, we have seen why so many supercomputers and data centers, why people are investing billions of dollars behind that. It is the necessity, right? And HPC is no longer to be limited to the traditional scientific computing domains. Okay, as we have seen, it is used for the special complex simulations, but its application will touch each and every field. So in essence, I will just say it's an important domain. It's a good idea to take a step ahead in this direction to integrate HPC, AI, data science, and all these relevant domains. And that's it from my side. If you are having any questions that are welcome, you can share your thoughts and feedbacks as well.
Okay, thank you, madam. Thank you very much for your wonderful session.
Thank you, sir.
Audience, please provide your feedback on the feedback shared to you, and as well as if you have any doubts, any queries regarding this session, please ask lively madam.
Okay, I will raise a question actually because
Okay, Oscar, please.
Yeah.
Please.
yeah, hello. So, ma'am, this is the question actually. What are the growth opportunities of in India right now? Because the session is more directed to the Indian audience, right? So, what you see for the next 5 to 10 years, right? What are the growth opportunities in India, and how we need to prepare the students for them for the next 10 years? How they to envision that?
Okay. Now there is an enormous growth opportunity in India because you just see over there are many programs are I can say arranged in this domain, right? In HPC, government is promoting this thing because in the new age or in near future we will be requiring, means every country will require, we can say, who wants to use the intelligence systems will need this computational power, right? So nowadays I also feel that students are not aware of this parallel processing, parallel computing, these things, right? So how we are working over here? Over here, we are working with there's a National Science Foundation over here, right, which works with the giving some curriculum recommendations. So we are including those topics which are related to basic topics related to the parallel programming, like OpenMP and the CUDA, right? Those things with the core subjects. And since we are having flexibility over here to change our syllabus, right, we can do that. Also, in India, if you want to do that, right, but with limited flexibility, even you cannot change the syllabus, but still you can include those things, right? And if you go to the different programs of this national supercomputing mission, you just go through that website, right? You will see there are so many efforts are done by the Indian government to put India at the forefront of this parallel processing and parallel programming things, HPC things. So yes, there is a enormous growth opportunity. This is a, we can say, new emerging area. Emerging area, I cannot say it's a new area, but yes, it is taking growth because of the that resource that are growing right now.
Okay, thank you, ma'am. And hopefully you can share the curriculum to Srinu garu so that he can at least take few sessions in the classroom so that everyone is aware that what is going on.
Yeah,
I'm
sure,
also working
sure.
for JP Morgan. I'm in New Jersey. So
Okay.
yeah. So we envision like growing markets of India is the data centers. Now the entire data is actually stored in India only. They are not allowing to go outside. So everyone on this, right? Yeah, data centers.
Right.
They look for those.
There-
What you need to prepare for that, and also
Right.
Tesla coming. Yesterday they said Tesla can come to India, right? So as Madam explained in the beginning, right, the Tesla and he invented the computers, right? Now they are coming India, so
Right.
more opportunities. Yeah.
There are
Thank you.
enormous growth opportunities in this field, I can say. And if you want to see the resources on how you can incorporate this parallel programming and parallel processing things into the syllabus, right? You can just go through the National Science Foundation's curriculum initiative on the parallel distributed computing, right? There are many different authors who have did this thing. They have shared their experiences over there. Even I'm also doing the same.
Yeah, thank you, ma'am. Thanks.
Madam, one more query posted in the chat box. What is deep sea compared to HPC, which will affect more?
What is?
What is deep sea? Deep sea compared to HPC, which will affect more?
DeepSeek. It might be DeepSeek.
Deep sea, yes, ma'am.
Yeah, I can say DeepSeek. Yes, I was, I think, about to cover this thing with this large language models, this training the deep learning or machine learning models, right? It fits into this category. Nowadays, we are using different Chat GPT or many other Gemini, right? Or recently launched DeepSeek, which has gained in some means the attention from whole world. Now it is also built on means we can say the high performance computing resources. But the beauty of that DeepSeek is that it has used the most primary chips from the NVIDIA. And they built or they trained the model, their open source model, with the very low cost. And the reason for that is nothing but they optimize their resources at the hardware level. Means the even NVIDIA, who is the, we can say, the resource provider itself, cannot create it, means they cannot create the same thing just because they didn't optimize their hardware. And the team with the DeepSeek, they optimize the simplest of the chip, I can say. Means not the latest one. They have not used the chips, the latest one that NVIDIA has launched, right? Which is, I think, banned from going outside from USA, right? Just before this news has came regarding DeepSeek, they did a work, the most basic work on optimizing that hardware level optimization they did, and they achieved the performance. So over here I can say that the basics of this parallel processing works.
Yeah. So adding to that, right? He again question, right? What is the use of HPC? If you fundamental think, right? HPC is the actual computational power. That's it at the bottom. But DeepSeek is the top layer. How it actually
Yes.
trains the feeds the data and try how fast, right? That's what it is doing actually. So both are essentially important, but HPC is the raw computational power. DeepSeek is the programming level on top of it. So
Right.
don't confuse anyone, right? So both are two different things. No, both
Different
are
things,
interlinked.
right.
Both are interlinked. Yeah.
Interlinked, right.
Thank you, sir. Thank you, sir. Venkata Guru and Rutal Mahajan from our overseas experts. One is industry expert, and one is academia and research expert. Thank you very much for your collaboration. And at the end, you made very graceful to our ATAL FTP on recent trends in high performance computing using artificial intelligence. This is the FDP sponsored by the AICTE ATAL organization by central government of India. We are very much thankful to ATAL organization for providing such a wonderful collaborative activities online and as well as offline for faculty fraternity to update their knowledge. Their formula itself, not only academia, only limited sessions for academia and remaining sessions shared to only industry experts and overseas experts. So, worldwide technological developments are incorporated for our students' purpose in the form of faculty. So, definitely, as we are elevating India, wherever you are, US or wherever you are, here India is also developing the technologically and in other economically is also. We hope in future we will reach a very sustainable state to provide good employability and good living standards to our Indian communities also. Thank you, madam. Till our session now. All the participants, if you have any doubts, eminent personalities are on the board. Please ask any related general queries also. We have 10 minutes. Time is there. Is it
Yeah,
any
yeah, breaking
participants?
extremes. Yeah.
Okay, madam. We unexpectedly we requested for the session. Thank you very much.
Thank you so
If you
much.
have any other assignments, you can leave, madam. Thank you, madam. Thank you.
Yeah, sir. Thank you, sir.
Thank you, ma'am.
Dear participants, all these 6 days ATAL FTP physically completed. Now it is the time for assessment. And I think okay, first assessment. Still okay. Now 6:30 to 7:30, we have the time for assessment and feedback.
So where is the exam link? You are going to provide in the chat or
No,
mail
no,
to
no.
some?
A separate ATAL portal is there actually.
Okay.
And
So someone asking give exam link.
yes, yes, everyone is having ATAL credentials. By their own credentials, they have to attempt exam. Then they have to
So-
submit feedback. Then only they will get a certificate.
Rahul Desai questioning that the link are they are facing the issue.
Now link will be activated by 6:30. After 6:30, sir. Actually, our session time is up to 6:30. ఏంటమ్మా క్వశ్చన్స్ అంటే వచ్చినాయా మనం సెర్చ్ చేయాలా అన్న
Srinagar, I just mentioned something on the chat. I think hopefully I answered someone's question. Now the exam is there.
గోడ కాగేది అట్లే చేసింది కదా మనుషులు కూడా చిన్ననే ఉన్నాయి చేద్దామని తెలుగు ఉన్నాయి కదా తెలుగు ఉన్నాయి కదా నిన్ను అడిగాను నేను
Vishnu sir, please mute.
So Srinu sir, it's 1 hour exam or a half an hour exam?
30 minutes exam actually.
Okay, 6:30 to 7:30. Okay.
Yes.
Someone asking any link, Nagalakshmi garu. You can provide the link so that they figure it out, maybe.
Questions are there? It's like
There is a question.
30 వస్తున్నాయా 7:30 to 80.
Okay, Srinu garu, the ATAL academy.aictindia.org login, that's the site, right?
They know. All the
They are asking
participants, everyone is know.
They are asking in the chat. Will you provide any link for the exam?
Vasu garu.
Yes, here.
Actually, the exam scheduled at 7:30 to 8, I think. So they have to try from 7 o'clock onwards. So 7:30 to 8. Exact time. The 20 questions, multiple choice questions are there. The 70% they have to qualify.
So it's 7:30 to 8.
They know they have to
So-
log in and check in their credentials. They will show their
So
login
your,
itself, system prompt.
So the after the exam, the welcome thing and feedbacks and everything will be scheduled, right? So it will be delayed by 1 hour.
Not, I think that will be delayed. So before we can conclude by 7 to 7:30, you can conclude, I think.
Why so slow?
Okay, so you are just doing that 7 to 7:30. So after that, they will go for the exam.
That is better, no?
That's better actually. If you move it forward, right? So
ఎప్పుడో తీసుకొచ్చింటారు. ఇంజక్షన్ అది కూడా ఉంది కదా. వద్దులే మళ్ళీ నీకు ఎగ్జామ్ వద్దులే ఎగ్జామ్
Okay, all the participants, please log into your ATAL portal and verify the feedback. But feedback will be taken after assessment only. And assessment is scheduled at 7:30. ATAL portal scheduled 7:30.